and before we begin exercise 10.2, I'm going to explain you theorem 10.2. So let's begin the theorem. Let's have a look at the statement. The statement reads that length of tangents drawn from external point are equal. If you see in this figure that I have drawn on the blackboard, P is a point which lies on the exterior of the circle, that means on the outside of the circle, and we have joined 2 points Q and R on the boundary of the circle with this point P. So you can see 2 tangents here. One tangent PQ and the other tangent PR. Let the center of the circle be O. Let's see what's given to us. We are given that P is a point on exterior of the circle. As you can see here, outside the circle we have a point P, and we have to prove that the length of these tangents PQ and PR are equal. So let's begin the proof without wasting any time. Alright, if you can see here, the very first thing you do is you will join the points. As you can see the points here, R, Q, P and O. Alright, so we'll write here join points OP, OQ and OR. This is the very first thing that you will do in that. Alright, now according to Theorem 10.1, yesterday we studied that tangents make an angle of 90 with the radius. Okay, so we'll write here that angle PQO and angle PRQ is equal to 90, and you can write here Theorem 10.1. Now let's prove these two triangles. As you can see the two triangles here, the first triangle is OPQ and the other one is OPR. We'll prove that they are congruent. So let's begin. We'll prove the congruency. In triangle OQP and triangle ORE, you can follow this particular figure along with what I write here. Alright, so in this figure what do we see? We see that first of all this distance from the center is the same. OQ is equal to OR, that is radius of the circle. Both are same. Okay, now the second thing, as you can see there, is OP is equal to OP, common segment. So you can write here common segment. As you can see here, for both the triangles, this segment is common. OP is equal to OP. Alright. So now, the third thing that we have is angle POQ. Angle PQO, sorry. Angle PQO is equal to angle PRO. If you see, that is a right angle according to Theorem 10.1. Both are right angles. So we can say that as they are right angle triangles, both are right angle triangles. Alright, so what have we proved here? It's a side. Okay. Then second thing, OP is OP, that is the hypotenuse. So you can write here S, H and this is the right angle. Okay. So lastly in the next line you will write that triangle OQP is congruent to triangle ORP by right angle hypotenuse side congruency. Hence we can say that the third side of the triangle, therefore PQ is equal to PR. Hence the length of the tangent proved here are equal. This marks the end of the theorem 10. Well, let's begin exercise 10.2 now after having finished the theorem 10.2. The first question reads, from a point Q, the length of tangents to a circle. So let's draw a circle first. Let's take a point Q outside the circle. Let's draw the tangent. Let the point where the tangent touches the circle be P. Okay. Now let the center of the circle be point P. Let's join this. That marks an angle of 90. And let's join these 2 points P and Q as well. So in the question we are given that from a point Q, the length of tangent to a circle is 24. So length of tangent given is 24 centimeters. Second, the distance of point Q from the center. This length, distance of point Q from the center of circle is 25 centimeters. And we are supposed to find the radius of the circle. Now according to Pythagoras Theorem, we know that if we are supposed to find either the base or the altitude, we have to subtract the square of the other side by the hypotenuse. So we'll write here, by Pythagoras theorem, let's take the side, PT is equal to under root of PQ square minus QT square. PQ square is 25 square minus 24 square. Let's expand this. 25 square means 25 into 25, that gives you 625 minus 24 square is 576. So in the last line you will write PT is equal to, when you subtract both the values 625 minus 576, you get the answer as under root 49. So lastly you get the answer as PT is equal to 7 centimeters, which is the square root of 49. So the answer of the radius of the circle is 7 centimeters. It means option A is correct. Now let's read the second question. What does the second question say in the given figure? Now we already given the figure here, so let's draw the figure first. In the figure we are given a circle, okay, and the center of circle is marked as O. The radius touches the circle at point P and point Q. When you extend this, you get two tangents joining at point T, which lies in the extreme of the circle. We are also given that one of the angle is 110 degrees and we are supposed to find angle PEQ. It means we are supposed to find this angle. Now we know that this particular quadrilateral is a four-sided figure. Okay, in quadrilateral P, O, Q and T, you can see 1, 2, 3 and 4. So we'll begin the sum like this. In quadrilateral P, O, Q, T, let's take the sum of all the four angles. Alright? Angle P plus angle O plus angle Q plus angle T is equal to 360. Now let's place the values which we have here. As you can see, this is the radius. It makes an angle of 90. Even this one makes an angle of 90 with tangent. So we have the measure of three angles here. Angle P is 90, implies that angle O is 110, angle Q is 90 plus angle T is equal to 360. Add all these three values, you will get the answer as 290. Okay, 290 implies that 290 plus angle T is equal to 360. Therefore, angle T is equal to 360 minus 290 degrees. So you can see that the answer you get is 70 degrees. Alright, so the correct option in the question that you see is option B. The answer is 70. Well, let's go to the next question. The question reads that if tangents PA and PB from a point P, okay, to a circle. So we already given a circle and a point P lies outside the circle. It is given in the question if tangent PA and PB. So let's take first point A, join this to the point P, the second point P, the other tangent form PB. Okay, now if these two from a point P to a circle with center O, let the center of the circle be O. So you can join these two radius. And we know by Theorem 10.1, these two form an angle of 90 with the tangent. Well, we have said that these two tangents are inclined to each other at an angle of 80 degrees. The total of measurement of this angle is 80. We have to find the measure of POA. So you join O and P, you have to find the measure of this angle. Now in the previous sum we have used the property of sum of angles of a quadrilateral. We will do the same here. Alright. What will we do is, we will take the sum of measure of all the angles in quadrilateral OAPB. Let's take the measure of all the angles here. Angle AOB, as you can see here, AOB plus angle OAP plus angle APB plus angle PBO is equal to 360. Now let's write the measures. As you can see, AOB is not given to us, so we'll write it as it is. Implies that angle AOB, angle OAP measure is 90 by theorem 10.1. Angle APB's measure is 80 given in the question. Angle PBO measure is 90 by theorem 10.1. Now add all these three. When you add all these three values, you get the answer as 260. So you will write angle AOP plus 260 is equal to 360 degrees. Taking this value on right hand side, you get angle AOB is equal to 360 minus 260, which is equal to 100 degrees. Alright, so the measure of angle, if you see, this is the measure of angle AOB, a complete angle. And in the figure, if you see, angle AOB is half of angle AOB, which is equal to half of 100 degrees, which gives you 50 as the answer. So you can see that the measure of angle POA or AOB is 50 degrees. And if you see in the options, this 50 degrees is the first option, option A. Let's move to question number 4. In question number 4, we have to prove that tangent is drawn in the end points of diameter. You can see in the figure, there is a circle with center P. The diameter is touching at point M and point N. There are two tangents touching the circle at point M and point N. We will prove that these two tangents AB and CD are parallel to each other. So first we are given, what is given to us? We are given that MN is the diameter and AB and CD are the tangents to a circle. We have to prove that these two tangents are parallel to each other. So let's begin the proof. In proof, we'll take tangent AB first from center P. Tangent AB. So the very first line that we'll write is AB is a tangent. AB is a tangent with point of contact. Now what is the point of contact for AB? M. Okay. In next line, you will write also PM is radius. PM is the radius. So you will write that angle PMA. According to theorem 10.1, tangent and radius lie perpendicular to each other. Okay, so we write PMA is equal to 90. You write theorem 10.1, 90 degrees. Okay, if I extend this line from P, it ends up at N. So I can write further, therefore angle NMA is equal to 90 degrees. Alright, as you write here, since MN is diameter. So similarly, for the second tangent, we'll write here CD is a tangent with point of contact Look at the point of contact here. Point of contact is N. Alright, and you can see here that when you talk about this tangent, Pn is the radius. So right here also Pn is radius. So you can see here that this angle will be 90. Alright, so you can write here angle D and P. Angle D and P is equal to 90 degrees. So if I extend this point from P towards M, I can write the same. This is according to theorem 10.1. Alright, so lastly I will write, therefore, angle M and D. M, N and D. This one. Alright, this will also be 90 degrees since MN is diameter. Now, if I take this one, this is number 2. point, and this is my first point which I have just proved. So if I see, then I will see that from 1 and 2, what do I see here? That the angle at the end point of diameter, both of them are 90. So I can say that angle NMA is equal to angle MNND. That angle is equal to this angle. Alright, so here I am going to write that from 1 and 2, let's erase this part. We need some space to write the remaining part of the sum. So let's write here from 1 and 2. What is the first point here? The first then deduction that we have done is angle NMA is equal to angle MND. Okay, this is what we have got. Or you can also say that, see, these two lines are parallel to each other. It forms an alternate angle. So you can write here alternate angles. Right? So in the last line you will simply write that these angles are alternate angles. Alright, and as they are formed by transversal, the transversal is MN and the parallel lines are AB and CD. Therefore we can write that AB is parallel to CD. This marks the end of question number 4. Number 5, exercise 10.2, we are supposed to prove, it's a rider once again, we will prove that perpendicular at the point of contact. Let's follow the diagram. The figures given to us. This is the perpendicular at the point of contact to the tangent. Here the tangent is PT. The perpendicular is drawn from center O of the circle. Okay, passes to the center. It means that there is no other line other than this one which will form an angle of 90 with the tangent. Which line? The line OT is the only one which will form an angle of 90 and no other line in this circle. Right? So let's begin the proof of this sum. First of all, we'll write PT is a tangent. PT is a tangent to a circle. As you can see here, PT is a tangent to a circle. Okay, and point M is inside, and point M is inside the circle. Inside the circle. Now suppose this point M was here at point O. Okay, so you write here circle such that MT is perpendicular to PT. Now according to figure, you can see the point M other than point O. But in the first case, we assume that M point is at point O. Then it forms a perpendicular to the tangent. Okay, MT is perpendicular to PT. Now, suppose if TM doesn't pass through this line, MT doesn't pass through center O of the circle. So you write here, suppose MT does not pass through center. It means this point M lies anywhere else other than passing through point O of the circle. Then we can say that here angle MTP is equal to 90. Now this angle MTP is not equal to 90 here. We have assumed it. Okay, here on top. Right? So we'll write here since MT is perpendicular to PT. According to this condition that we have stated, it should form an angle of 90. Alright? Here, so we can write here, therefore angle OTP is equal to 90 as O is the center of circle, OT is the radius and TP is the tangent. Alright, so we write here according to Theorem 10.1, the radius of the circle forms an angle of 90 with the tangent to the circle. Right, so lastly we can say that therefore angle MTP is equal to the measure of angle OTP. This is possible. Okay, this condition is possible. You write here. It is possible only only if OT and MT, these two lines, OT and MT, they coincide. Coincide means they overlap each other. They are over each other. Okay, only then they can pass through. If that means the point M, the line MT, it should pass through the point O. Alright, hence we can say that the perpendicular at the point of contact, the tangent of a circle passes only through the center of circle and not anywhere else. This must be end of the sum.